Student, now we are going to solve the exercise 6.2 class 9 general maths question number 6. As you can see in the video, the two mirror PQ and RS are placed parallel. Now one ray, incident ray is AB, it reflects, strikes into the point B and it reflects back to the point C through BC, and again it strikes back to the point D through CD. We have to prove that AB parallel CD. I repeat again, we have to prove that AB parallel CD. Now let's have a look, student, how to solve this one. This question number 6. Student, this is diagram of question number 6, class 9, general maths exercise 6.2. The diagram, as you can see in the video, the incident ray A. Here I have given I means angle of incidence and R means angle of reflection. Now we have to prove that AB parallel CD. Just I have drawn here the normal. If it is an incident ray and if it is a reflected ray, then between these two we can draw the line. It is called normal. So this is actually the concept of law of reflection. Now if we draw the line here, it is normal, or we can say that BL perpendicular to PQ, and here also CM is the normal again, and CM is perpendicular to RS. Now look how to solve this one, student. Given part I have written from book, and to prove also I have written from the main book. Now the construction part I am writing here, construction. So here, students, I will write down that we draw ray BL perpendicular PQ and CM perpendicular RS. This is the construction part. Now we will start the proof here. Let's have a look how to start the proof. Student, as you can see in the video, this is a rough sketch which I have drawn in a small piece of paper so that I can solve this question very easily with the help of this paper. Now look, the proof part I will start here now. Proof that I am writing here, proof. Now look, student, PQ parallel to RS. It is given in the question, PQ parallel to RS. Now after drawing that BL and CM as a normal into the these two part, or perpendicular BL perpendicular PQ and CM perpendicular RS. So BL and CM is also parallel. If we extend here and if we extend there, so these two also parallel, and BC is the transversal between these BL and CM. So students, what we will write here now? Look, I am writing that answer. Since we will write down here, since PQ parallel RS, PQ parallel RS, it is given part. So we'll write down here given in the bracket. Now look, student, therefore we'll write down that BL parallel CM. Why? The reason is actually here we'll write down since BL perpendicular PQ and CM perpendicular RS. This is from construction. Whether you will write this line whole or you can write directly from construction. Now student, look here that BC is the transversal. So if BL parallel CM and BC is the transversal, Now look after that, student, if BL parallel CM and BC is the transversal, then we can write down here that angle LBC, which means this angle LBC equal to angle LBC means this angle equal to angle this one MCB. Why? This is alternate ALT dot, alternate interior INT dot, alternate interior angle. Now student, one more thing is that we can also say that angle of incidence equal to angle of reflection. Here also same, angle of incidence equal to angle of reflection. Now look, student, after that, student, I am taking this one as our equation number 1. Now look, one more thing here, just write down A. Now look student, if it is I means angle of incidence, so ABL equal to LBC means angle of incidence equal to angle of reflection. Similarly here also student, BCM equal to DCM, angle of incidence equal to angle of reflection. Now look students, here I can write down that angle ABL equal to angle LBC. Reason, angle I equal to angle R, which means angle of incidence equal to angle of reflection. Angle of incidence, I means incidence, angle of incidence equal to angle of reflection, angle R means reflection. Student, this is the law of reflection actually. Now look student, one more thing is that also. So student, from equation 1, and if I take this one as our equation number 2, then look here, in both the cases from 1 and 2, this equal to this two cancel because equal. Now look here, I am writing that from 1 and 2, that I will write down LBC cancel, so angle ABL equal to MCB. Now look after that, again from the diagram, look here now student, if we take this part again, that this is angle of incidence and this is angle of reflection, so MCB equal to MCD again. Now taking this one as our equation number 3, now again angle MCB equal to angle MCD. Why? Reason is angle I equal to angle R, which means angle of incidence, angle of incidence equal to angle of reflection, So if we take this one as our equation number 4, now from 3 and 4 what will happen student? Look here now, MCB cancels, so remaining part would be here, that after, so we'll write down here from 3 and 4, that MCB cancels, so angle ABL equal to angle MCD. So this is our equation number 5. Now student, look the last part. Now student, if we add equation number 1 and equation number 5, if we add these two, 1 and 5, then what will happen? LBC plus ABL and MCB plus MCD. Now look into the diagram once. Equation number 1 LBC plus equation number 5 ABL. So LBC, which means this part, ABL this part. So if we add these two, it becomes ABC, which means this whole angle. And if we add MCB and MCD, MCB and MCD, so if we add this, it becomes whole, which means BCD. I repeat again, if we add LBC and ABL, so it becomes ABC whole, and if we add MCD and MCB this whole, so it becomes ABCD. Now look student, after that, now student, now equation 1 plus 5, then what will happen here? Look here now, 1 plus 5, then equation ABL, equation ABL plus equation LBC equal to equation MCD, equation MCB plus equation MCD. Now look, if we add this, so it becomes ABL plus LBC, so it becomes equation ABC. Now if we add this to, it becomes equation BCD, or angle ABC and angle BCD. Now look student, after that, if it is do so, if this angle and this angle are equal, then what we will say regarding that? we'll say that these two are the interior and alternate interior angle. So we'll write down here, therefore angle ABC and angle BCD are the alternate interior angles, and we know that alternate interior angles are equal. Therefore, student, the last line will be here. Now in the diagram, look once. If these two angles are the alternate interior angles and these two are equal, so we'll say that, AB parallel to CD. Therefore, the last line will be here like this. We'll write down here. Therefore, AB parallel to CD, which is our proof. Look into the diagram once. Which is our proof? So we'll write down hence proved. This is the proof of the question number 6.